Hello all, this is Mr. G, and after this video we should be able to use ratios to compare the sides of right triangles. And remember, ratios, whenever you hear that word, you should think all a ratio is a comparison by division. A comparison by division. So no matter how complicated a ratio looks or sounds, all it is we're taking two things and we're comparing them. That's it. The more you keep that definition in front of your mind, the easier this whole video is going to be. Now, to get the most out of this video, you're really going to want to have a calculator with you while you're watching. You can either have like a phone calculator or one on a laptop or an actual physical calculator. All you need to be able to do is divide numbers. Any calculator that'll do that will work fine for this video. So let's take a look at what we're going to start with. We're not going to start this video with an example or a definition or any vocab or anything like that. We're actually going to start with an activity where you're going to be finding each ratio for the given triangle. Now, I'm going to do the first one with you so you can follow along, but after that, it'd be good to pause it and try the rest on your own. That's how you get the most out of this activity. But let's jump right in. So we're finding each ratio, and the first ratio is the leg not connected to the number at acute angle compared to the hypotenuse. Okay, so the hypotenuse, that's not too bad. The denominator is pretty simple here. So the hypotenuse in this triangle, well, let's see, the right angle is an arrow pointing at the hypotenuse. So the hypotenuse is right here. So the hypotenuse would be 23.8175. 8175. This numerator is slightly more complicated. So let's read this again. It's the leg. So a leg is anything that's not the hypotenuse. So it could be this side or it could be that side. And it's saying it's the leg not connected to the numbered acute angle. Well, the only numbered acute angle they give us is that 40 degrees. So essentially they're talking about angle A here. And the leg that's not connected would be not this one, but this one right here. Because this leg is touching angle C and angle B. It's completely missing angle A. It's not connected to that 40 degrees we have on angle A. So that's going to be our numerator. It's going to be 15.3096. And now we just need to plug that into the calculator to see what we get when we divide. So it's going to be 15.33096 divided by 23.8175. Did I type that correctly? 15.3096, 23.8175. Then we're going to hit enter, and we get 0.642, and we'll round that up to an 8. So that's our first ratio here. That's the first decimal we get. Now at this point, if you want to get the most out of this video, hit the pause button and try the rest on your own. All right? I will go over the answers in 3, 2, 1. Let's roll. All right, so we're still talking about that angle A, because we're talking about still the numbered acute angle, but it's a leg connected to the numbered acute angle compared to the hypotenuse. So we're still using the hypotenuse as the denominator. So we're still using that 23.8175, but the leg that's connected this time to our angle of 40 degrees. So the connected leg would be right there. So the numerator this time is 18.2453. And then we're going to plug that into the calculator, see what we get. 18.2453. Divide that by 23.8175. Type that correctly. 8175. Hit enter. And we get 0.7660 it rounds to. And the next one is the leg not connected to the numbered acute angle compared to the leg connected. All right, so now we're just comparing the two legs, and we want, so we get rid of the hypotenuse, and it's not connected, so that one's first, to the one that's connected. So it's 15.30, what was it? 3096. And we're going to divide that by 18.2453. And let's see what we get. And 15.3096, divide that by 18.2453, and we get 0.8391. Okay, so we finished our first triangle. There's actually 2 more triangles to go. So let's take a look at this one. Again, if you want to get the most out of this, pause the video right now, fill in these answers, and then come back and check yourself. But in case you need help, I'm going to go through it in 3, 2, 1. Let's go. All right. So it's actually the same three ratios. Leg not connected to hypotenuse is first. So this is still our angle, that numbered acute angle. And the leg not connected would be 12.5530 compared to the hypotenuse is that right there, which is 19.5290. Let's type that in. We can clear that out. 12.5530. Divide that by 19.5290. And that comes out to 0.6428 in rounds two. All right, next up we've got the leg, let's get rid of all that. We've got the leg connected to the numbered acute angle, which is that leg. Oh, and the hypotenuse. We still need the hypotenuse. I didn't need to erase that. And that will be 14.9601, all divided by 19.5290. And let's see what that comes out to. 14.9601, divide that by 19.5290, and we get 0.7660. And last but not least, leg not connected to the connected leg. So this time we actually do need to get rid of the hypotenuse. And not connected leg is 12.55, and the connected leg is 14.96. So let's write that down here. 12.5530, all divided by 14.9601. And let's divide and see what we get. 12.5530, divide that by 14.9601, hit enter, and we get 0.8391. Okay. Just one more triangle to go for this activity, and I know this probably seems tedious, but if you want to get the most out of this video, you really need to pause right now, try this on your own, fill in those numbers, get your decimal answers, and then hit play and check your answers, and we'll move on from there. So pause, and then we'll go over in 3, 2, 1, let's go. All right, so this is our numbered acute angle, that angle this time, and the first ratio is leg that's not connected to it compared to the hypotenuse. So this time that's going to be 9.3731, and we divide that by 16.3416, and let's see what we get. 9.3731, divide that by 16.3416, and we get 0.5736 it rounds to. All right, next up, still using that numbered acute angle, is connected leg to the hypotenuse. So in this triangle, it's 13.3863, all divided by, what is the hypotenuse? 16.3416. And let's see what we get. Clear that one out. 13.3863. And we divide that by 16.3416. And we get 0.8192 it will round to. And last but not least, we've got the leg not connected. So the leg not connected is right here. So the leg that's connected, which is right there, connected to that angle J. And we get 9.3731 divided by 13.3863. All right, plug that in. 9.3731. Divide that by 13.3863. Hit enter, and we get 0.7002. All right. So now what we're going to do is we're going to take a look at all these decimals in one spot, and that hopefully you found along with me. You didn't just sit there and watch. So here's, you should have a table that looks something like this. And really, I want you to take a second, and if you need to pause the video, by all means do it. What patterns do you notice? So what patterns do you notice in your table, which hopefully looks a lot like mine? What do you notice here? Well, I see a lot of the same numbers showing up. I see these two, and those two. So essentially we've got, for the first two triangles, triangle ABC and triangle DEF, the ratios of the two sides came out exactly the same. But in JKL, we got completely different numbers here. So triangle JKL does not follow the pattern. Now, let's take a look at our three triangles together and ask ourselves, why might that be? Why would this one follow the pattern? Why would this one follow the pattern? But why would this one not? Hopefully you're noticing it's because the angle changed. The numbered acute angle changed. We went from 40 degrees to 35 degrees. And when we changed that, all of a sudden the ratios of the sides did not come out to the same decimal anymore. And that shouldn't surprise us because these two triangles, since they had a congruent 90-degree angle and a congruent 40-degree angle, essentially they have two pairs of congruent angles. That means they are similar. This one is not similar to the other two, which is why it doesn't follow the pattern of the side ratios, or the ratio of the sides, I should say. And again, we should not be surprised that similar triangles gave us the same ratios, because when we have similar shapes, that means that the sides are proportional. So a lot of this connects back to what we were doing in our last chapter on similarity, ratios, proportions, all that stuff. So we actually have names for these ratios of the not connected leg to the hypotenuse, the connected leg to the hypotenuse, and the non-connected leg to the connected leg. Because math people, we kept noticing those ratios throughout history. They kept being the same, the same, the same. So we said, okay, we're just going to come up with some names for them. So these are called trigonometric ratios. So essentially we're starting trigonometry. And what you just did, if you followed along with the video, you discovered these ratios for yourself. You discovered the ratios of sine, cosine, and tangent. So sine is what, oh, and we abbreviate that SIN, but we don't say sin. We still say sine. So sine of an angle is the non-connected leg over the hypotenuse. So in this triangle right here, if we're focusing on that angle as our home base, sort of our reference angle, the non-connected leg would be 3, and the hypotenuse would be 5. So sine of this blue angle would be 3 over 5. And the cosine, which we abbreviate COS, so we would read this cosine of the angle is the connected leg over the hypotenuse. So in this triangle up here, the connected leg would be 4, and the hypotenuse would be 5. And last but not least, the one that everyone always forgets about, unfortunately, tangent is sort of the odd man out. So tangent, we abbreviate TAN, but we don't say tan, we still say tangent. I don't want to hear anyone saying sin, cos, or tan. It's sine, cosine, and tangent. Anyways, back to tangent. We would read this as tangent of the angle, and that's the non-connected leg over the connected leg. But we actually have, oh, I forgot to, let's get the numbers there. So the non-connected leg is 3, and the connected leg is 4. So we just found our trig ratios, our trigonometric ratios for this triangle. But we actually have some better vocab besides like non-connected leg and connected leg, because if we're focused on, let's do this in a different color so it stands out. If we're focused on this angle right here, the non-connected leg of 3, that's across the shape from it. So the side that's across an angle, that's called the opposite leg. So we can also call sine the opposite over the hypotenuse. Now the cosine, the connected leg to the hypotenuse, again, if we're focused on this leg, that blue angle, the connected leg is 4. And 4 we would actually call the adjacent leg, adjacent meaning next to. So cosine we can call adjacent over hypotenuse. And then tangent, we just went over this vocab. Non-connected is opposite, and connected is adjacent. So we have sine being opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And at this point, I wouldn't blame any of you watching this if you were thinking, wait a minute, I've got to memorize all of that? What's going on with this? That's too much. No, you actually don't. Because there's one stupid word that will give you all of that information, and we call it SOHCAHTOA. SOHCAHTOA. Essentially, it's broken up into 3 parts. This, and this. It's essentially 3 groups of 3 letters. Now, this is very much like PEMDAS, if you remember that from, I don't know, 5th grade, 6th grade, whenever you did that. And what PEMDAS is a stupid word that gives us the order of operations. Because when we see PEMDAS, we think, oh, parentheses, exponents, then multiplication, division, addition, subtraction. Each letter is a key to something you need to do. Same thing with SOHCAHTOA. The S stands for sine. So it tells us the sine of the angle, and then the O stands for opposite, and the H stands for hypotenuse. The C stands for cosine, so we have cosine of an angle, equals the A stands for adjacent, and the H stands for hypotenuse. And last but not least, we've got TOA, the T standing for tangent, so we have tangent of the angle, equals O stands for opposite, and A stands for adjacent. And there we go. This one stupid made-up word SOHCAHTOA gives us all the formulas we need for these special ratios, these special comparisons of sides in a right triangle. Now, it's absolutely critical that you have this word memorized. If you don't have this word memorized, you will not be able to do any of the work we're doing in trig. So whatever you need to do to memorize this word, make sure you memorize it. I don't care how you pronounce it, just make sure you can spell it properly. That was a lot of lead up, but now we're finally on our first example for this video. They give us this triangle HJI, and what we need to do, we need to find each trig ratio, meaning trigonometric ratio, in the given triangle. And when we're looking for these trig ratios, the first thing we should either think or write down is SOHCAHTOA. So that's what I'm going to do. I'm going to write down SOHCAHTOA. Now, this is sine of H. That's first up. So we're talking about angle H. So we're sitting on that angle. That's our reference angle. And sine, if we look at PEMDAS, if we look at SOHCAHTOA, which is very similar to PEMDAS, it's O over H. So that's opposite compared to the hypotenuse. And let's see. Opposite of H, if we go across from H, that's 5. Over the hypotenuse, that's 13. That's it. We're done. They asked us for a ratio of those two sides. That's what sine means. They're asking us for a ratio of two sides. We gave it to them. That specific ratio of the opposite leg compared to the hypotenuse. That's all they wanted. All right, next up is cosine of H. So we have to turn our attention to the middle part of SOHCAHTOA, the CAH, because remember, C stands for cosine. So we're still focused on angle H, which is good. And let me see. So cosine, if we're looking up here, it's adjacent over hypotenuse. And adjacent, the adjacent leg is the leg that's touching our angle of H. That would be 12. Over the hypotenuse, well, that's still 13, because that's across from the 90-degree angles. And we're done. Or did I say 90-degree angles? There's only one. It's across from the 90-degree angle. There we go. And that's it. 12 over 13, all done. Next up is tangent of H. So we're still on H, but now we have to focus on the final part of SOHCAHTOA, the TOA. O standing for opposite, A standing for adjacent. And if we're looking at angle H, opposite would be 5. That's the opposite leg. Over the adjacent leg is 12, because that's the side that's right next to, that's the leg that's right next to our reference angle, our home base angle of H. And 5 over 12. And we're finished. All right, last up, we've got sine of J. Now, some of you might be tempted to think, oh, sine? We already did sine. Let's just make that 5 over 13 and move on with our lives. But that would be incorrect, because this is not sine of H down here. Up here, we found sine of H. But down here, they're asking us for sine of J. So we're changing our reference angle. We're changing where we're sitting on the triangle. We're sitting on angle J now, looking at the triangle from that perspective. Now, let's think about it. Is any of that going to change? I mean, the hypotenuse, that's still going to be the hypotenuse. So let's actually go back and label. So when we were on H, 13 was the hypotenuse, and 5 was opposite, and 12 was the adjacent. But if we change, and let me do this in a different color. If we change to angle J, I mean, this is still the hypotenuse because it's still across from 90 degrees. But all of a sudden, the opposite and adjacent change places. All of a sudden, 12 becomes the opposite leg, the leg that's not connected to our angle. And, okay, we'll just leave that there, I guess. And 5 becomes the adjacent, because now this leg is right next to our target angle, our angle of J. So that's really important to remember. So whenever you change the acute angle you're focusing on in a right triangle, the hypotenuse stays the same, but the opposite leg and the adjacent leg switch places. So be on the lookout for that. I guess we can keep going green. So sine of J, again, that's opposite over adjacent using that first part of SOHCAHTOA. That's what the S stands for, sine. And it's opposite over hypotenuse, which will be, what's that going to be? 12 over 13. 12 is opposite for the green, and 13 is always the hypotenuse. So 12 over 13, and we're finished. We found our trig ratios. I want you to try example 2 on your own. So pause the video right here, give these problems a shot, and come back when you think you have an answer. We're going over in 3, 2, 1, let's roll. Okay, find each trig ratio. As soon as we hear trig ratio, I think, okay, we need SOHCAHTOA. So I'm going to write that down. The more you write it down, the better you'll have it memorized. So hopefully you're writing it down for every single one of these examples. Now, sine of A, we're focused on A degrees right there. We're looking for sine here, so we have to focus on the first part of SOHCAHTOA, the SOH, which means sine stands for opposite over hypotenuse, which will be opposite of A is 5. And the hypotenuse is going to be 10. So it's 5 over 10, which simplifies to 1/2, and we're done. Remember, you always want to simplify your fractions if you can. Erase that. That looks better. Next up, we have cosine of A. So we're still focused on A. We don't have to change our reference angle, sort of our home base, our where we're looking at the triangle from, but we do have to change what we're looking at in SOHCAHTOA. Now we're focused on CAH, the adjacent over hypotenuse. Adjacent to A degrees is right there, so that's 5 square root 3. So we can put that in the numerator. And we know the hypotenuse is 10. Now here, don't let this square root symbol throw you off your game. You know how to simplify this. You can simplify, let me highlight this. Just simplify the 5 over 10. We can't divide the 3 by the 10 because the 3 is inside a square root. The 10 is not. But we can simplify that 5 over 2, so that's just 1/2 again. So we get 1 square root 3 over 2. And actually, we could have saved ourselves some time. We don't even need this 1 in front because it would be 1 times the square root of 3, but 1 times anything is itself. Multiplying by 1 doesn't change anything. So we can just write it as square root of 3 over 2. We can move the triangle down so we can follow this easier. So now we're on sine of B. Okay, big change. We're on B degrees now. We've changed our reference angle. We've changed our sort of point of perspective. Now, well, okay, let's bring down SOHCAHTOA as well, so we can see that in the video. Come on, smartboard, work with me. Bring down SOHCAHTOA and this. So it's sine, which means we're actually going back to the first part of SOHCAHTOA, SOH. So sine is opposite over hypotenuse. That's what the O and H stand for. And opposite angle B would be 5 root 3. So we bring that over, 5 times the square root of 3. All divided by the hypotenuse, that's still 10. And we get, oh, that simplifies to 1 square root 3 over 2, because the 5 and 10 divide to 1/2. So we can just make it square root of 3 over 2. So we get square root of 3 over 2, which is actually really familiar. We just got that same answer up here for cosine of A. So cosine of A degrees and sine of B degrees ended up being the exact same thing, which I guess shouldn't surprise us all that much, because remember, if we change our reference angle, if we go from angle A to angle B, what changed? The hypotenuse stays the same, but the opposite and adjacent switch places. And the only difference between cosine and sine is one has the adjacent in the numerator and the other has opposite in the numerator. So if opposite and adjacent switch places, we're going to end up with the same number, which we did. We got the 5 square root 3 in both places there. It's adjacent to one angle, but opposite to the other. So that's going to be a real good pattern to notice going forward. Anytime you change, how do I want to say this? Let me say this way. Sine of one acute angle is going to be the same as cosine of the other acute angle. So for example, the sine of B would be the same as cosine of A. And the sine of A is the same as cosine of B. That's the way that pattern works. All right, last but not least, we've got tangent of B. So let me scroll this down so it's away from the writing. Focused on B degrees and its tangent. So we look at the last section of SOHCAHTOA, the TOA. Tangent is opposite over adjacent. And what do we get there? So opposite b degrees is 5 root 3. And the adjacent leg would be 5. So there, and I'm going to need some more space to show my work so I can slide that out. We don't really need the triangle anymore anyways. Well, here we can just do the 5 divided by 5, and anything divided by itself is just 1. So we get the square root of 3 over 1, or we could just write it as the square root of 3. And we're finished. So hopefully you got those answers on your own, or if not, hopefully it makes sense now. Do we have any more? Oh, yeah, one more slide to go. This is our final example for this video. So give this problem a shot on your own. I think you can handle this. So pause the video right here. Come back when you think you have an answer. We're going over in 3, 2, 1. Let's go. So here it says choose the triangle or triangles where tangent. Oh, I'm not sure we've seen this symbol before. So hopefully that didn't throw you off too much. But basically this symbol, let me write it down here. This just means theta. Okay. Now this is a new variable. Well, it's not a new variable. It's a new variable to us in this video, but it's actually an old Greek letter that we use as a variable, and we most often use it as a variable for an angle. So since we're talking a lot about angles in trigonometry, that variable theta starts showing up more often. So whenever you see that, just think, oh, that's just a variable. We don't have to get freaked out by that. So we have to choose the triangle or triangles where tangent theta equals 2 over 3. This is very different from the other examples because here they're giving us the ratio. Instead of us finding the ratio, they're giving us the ratio and we have to choose the triangle. So we're sort of working in reverse here. Well, let's think about SOHCAHTOA. So in SOHCAHTOA, if we're talking about tangent, we're talking about this section right here. So that would be opposite over adjacent. So essentially we're looking for triangles where the opposite over adjacent equals 2 over 3. So let's just sort of guess, not guess and check, but sort of go through it. Use process of elimination, go through these one by one. So in this triangle, theta is right there, and opposite would be 2, adjacent would be 3. So yeah, we get 2 over 3. So this one is good. So we found one answer, but it does say there might be more, so we've got to keep going. Let's take a look at this one. We'll do these in different colors to help them stand out. So here's theta, that's our reference angle. Opposite would be 15, the adjacent leg is 10, so that's 15 over 10. We can simplify that, divide them both by 5, and we get 3 over 2. Okay, so that's not one we want. We got the same numbers, 3 and 2, but they're in the wrong order. And remember, these trig ratios, it's all about comparing the two sides in the correct order. So even though it's close, it's not good enough, unfortunately. Let's take a look at the next triangle. There's theta. Opposite is 12, adjacent is 18. We get 12 over 18. And we can divide them both by 6 and get 2 over 3. So that's another correct answer. And last but not least, this final triangle, there is theta. And opposite would be 7, adjacent is 21. So we get 7 over 21. We can divide them both by 7 and get 1 over 3. So that's not what we're looking for. That's not the correct tangent ratio because we wanted it to be 2 over 3. So the first triangle was an answer and the third triangle was an answer. Just those two. So hopefully that's the answer you got on your own. Hopefully this video made sense. As always, if you have questions on the lesson, reach out to me. Let me know. Enjoy the rest of your day.